Hello everyone. In this video, I will very briefly talk about the easing that we can do for our linear interpolation. So in my last video, I was working and learning about linear interpolation, and this helps us move from one point A to a point B linearly. And so whenever I want to move from one point to another, I can use linear interpolation. Okay, that's really quick. I'm just going to make it a little bit slower. Okay. And so how does linear interpolation work? We have my time parameters, t, big T. We reset t every time we press the reset button, and we advance time every time every frame. We advance the time by the difference in time between frames. And then we find our lambda parameter. That's going to be, in the case of linear interpolation, that goes from 0 to 1, and like half would be halfway between the different points. We get this lambda parameter by just dividing t by big T and clamping it between 0 and 1. And then we use the linear interpolation function to go from the start to the target by this lambda, where the start is the player position when we pressed reset. The target is a random point, which I'm visualizing with this heart position. So the question is, how can we make this a little bit more fun? So, like, if this is my time function, this is t, and this is, how's it called, the position. At the moment, what is happening is that we're just going on a straight line from the beginning to the end, right? But there is a couple of things that we could do, which would be to ease in or to ease out. Sorry, this would be, yeah, that would be to ease out, and this would be to ease in. So it would be like arriving a little bit, if this is like my hand. So instead of moving like this, we want to move slowly then fast. Or we want to move fast and slow down as we reach the point. Or indeed, we could do both. We could do like ease in and out. So the question is, how can we do this? And the answer is, we can change the parameter lambda by a function. And so let's just write that. So let's make a function f, which takes my parameter, which I'm going to call it x here. And it returns also a float. And this float is going to be, the return is going to be x times x. And we do that to f of lambda. And so what will this do? We know the y is equal to x squared function, what that looks like. That's just like this, right? But interestingly, it goes through the 1, 1 point and through the 0, 0 point, because 1 squared is equal to 1. So this is going to be a good approximation for an is out kind of function. So if we now reset, as you can see, the cat speeds up after I press the reset button, and it eventually reaches the heart. So this is an example of how we can do an ease out with the same linear interpolation, just easing with a function. A similar would be to do, well, what if we had like a parabola that is like this? So all we need to do is like flip everything on its head. So we replace like x with 1 minus x. And so we have like 1 minus x all squared. And this is my y equals this function. So before it was like this, but now it's going to be 0 at 1. It's going to be like this, right? And now if I do y is equal to 1 minus x squared, I am now flipping the parabola. And now it will look like this, where this is my 1, 1 point and my 0, 0 point. And we can verify this. If x is equal to 0, well, there's going to be 1 minus 0 squared, that's 1, and 1 minus 1 is 0. On the other hand, if I have 1, then now this is 0, and then all of this is 1. Let's actually have a look at how this looks at. So I do 1 minus x times 1 minus x, and we reset that. And now what it does is it starts moving very quickly, and it slows down as it gets close to the heart. And the amount of time it takes is exactly 1 second, but we could make that faster or slower by changing this parameter. But it's still going fast and then slow, fast and then slowing down as it reaches. Okay, how can we do is in and is out? Well, one way to do this is to use the cos function. So we know what cos looks like, right? That would be cos of x. But we want it to go, so it's going from like 0, 1 all the way to, well, here it would be pi, and it would be -1. But it does have this like wavy shape where it's going one way and then the other. And so how can we do it? So we can do, well, if we multiply it by 0.5, it's now going from like 0.5 to -0.5. If we divide or multiply x by pi, now this is going to be 1 here instead of pi. And finally, if we do 0.5 minus what we have above, that is finally going to arrange it so that it now begins at 0 and ends at 1. Because 0.5 minus 0.5 is 0, but 0.5 minus 0.5 is actually 1. And so the final function is going to be 0.5 minus 0.5 times the cos of x times pi. So now if we reset, it slows down. It starts slow, it speeds up, but then it slows down as it reaches the heart. Okay, and that can also work quite nicely if we're moving a bit faster. As you can see, it kind of like speeds up, but then slows down as it reaches a point. And it's slightly less jarring than if we just do the lambda, because then it just instantly speeds up and instantly slows down. Okay, now Godot actually has an ease function where you set lambda and another parameter. So for example, this happens when the ease parameter is 1, but when it's 0.5, as you can see, now we have an ease out kind of motion. And when it's instead bigger than 1, such as 2, then it's, actually no, this is the ease out, right? Whereas if it's like 0.2, it starts fast and then slows down. So this is an ease in. And in this case, if you actually go to negative numbers, so minus 0.5, this is like a very funny one because it kind of like starts fast but slows down and then speeds up again. But on the other hand, if you go beyond -1, you have, once again, it speeds up and then it slows down. So an easing out kind of function. Yeah. different programming languages might have a similar ease function, and that can be very useful. But you can always come up with your own formulas if you want to. The most important thing is that it's a function that goes from 0, 0 to 1, 1, and that it connects more or less in the shape that you want it to. Sometimes that shape can actually be quite funny. I've seen some people use easing where you have like a little bounce as you reach, and that would look like it bounces as it reaches the objective. So yeah, we have learned how to use easing together with our linear interpolation to create some pretty fun things.